Welcome to Thought Frontier.
Well, get ready to stretch your brains a bit. Because today we're really diving deep into something that's been a head scratcher for, well, pretty much ever, the observer's role in quantum mechanics. And judging by the stack of articles you all sent in, seems like you're just as eager to unpack this as we are.
It's one of those things where, honestly, the science starts to sound a bit like something out of sci-fi. But here's the catch, the implications. They're anything but fiction. We're talking about looking at the very nature of reality, like what is real even.
Okay, so before we go full-blown existential crisis here, let's start simple. What is it about quantum mechanics that makes the observer so important in the first place?
All right, so picture this. You're flipping a coin. Simple, right? 50-50, heads or tails, and quantum physics. Amazing at those odds, right on the money with the probabilities. But there's this little thing. It doesn't actually tell us why on that flip it landed the way it did. Why heads this time and not tails? What's deciding that?
So it's not just that we don't know, it's more like the theory itself is silent on that specific outcome, like actually becoming a thing.
Exactly. And it's not just some tiny detail either. It gets right to the heart of how we even interpret what's going on in the quantum world. It's where interpretations like Copenhagen and many worlds come in. And here's the kicker. They both place the observer, well, front and center, surprisingly so.
All right, you've definitely got my attention. Let's unpack those interpretations. Copenhagen, what's the deal with observers there?
So remember that coin. Copenhagen basically says that until someone actually looks at the flip, it's not really heads or tails. It's in this fuzzy, undefined state of maybe both. It's the looking, the observation itself that forces the universe to show its hand, to collapse those possibilities into just one outcome.
So it's like we're saying, hey, universe, pick a card, any card, and the universe is all, fine if you insist, heads it is.
Uh-huh. I like that. And to really see this in action, there's that classic thought experiment, Schrodinger's cat in a box, 50-50 chance of, well, bad things. Copenhagen says until that box is opened, cat's not really alive or dead, just this blurry, maybe with, until, bam, observation forces a single outcome.
Okay, that one still messes with me. But you said earlier it doesn't have to be a conscious observer. What's the deal with that?
Right, right. Modern takes on Copenhagen suggest it's more about the quantum system, in this case, the poor cat, interacting with a larger system, something more, normal, the observer, or even the measuring device itself. The point is, it's the act of measuring, the interacting, that forces the quantum system to choose. But even then, the observer, still calling the shots on what that final outcome looks like.
Okay, so with Copenhagen, it's like we're making the universe pick a card, even if it doesn't realize it's playing. But then we have many worlds, and that one's a whole other level of whoa. So what's the observer up to in that interpretation?
Many worlds, well, it takes a different approach altogether. Much more radical, you could say. It says there's no collapsing of possibilities at all. Instead, get this, every single quantum measurement, every coin flip, every peek into Schrodinger's box, it all causes the universe to, get this, branch. Each possible outcome gets its own separate universe to play out in. Wild, right?
So with the cat, instead of one reality where it's this weird, maybe alive, maybe not situation, there are now two realities side by side. One where the cat's fine and another where not so much.
Precisely. Now, hold on tight, because this is where the observer comes in with many worlds. It's not that we're creating these branches, these realities. It's that our observation determines which branch we end up experiencing as, well, our universe.
So it's like those choose-your-own-adventure books, but like Cosmic Edition. We don't write the story, but the choices we make determine which path we go down.
That's a fantastic way to put it. And actually, speaking of stories, there's this short story, Divided by Infinity. Really captures what living in a many worlds reality might be. Like every choice, every observation creates a new you in a new universe.
Right.
And get this, people can send messages between these branches. Makes you think, doesn't it?
I'll have to check that out. Amazing how fiction can make these really complex ideas, well, easier to grasp. But it is interesting that whether it's Copenhagen or many worlds, the observer is still key. Collapsing possibilities or choosing our path in the multiverse, we're definitely not just watching from the sidelines.
It really makes you wonder what is real, even if just looking at something might be changing it. But it gets even more interesting, this observer idea. It's not just physics.
You're saying it pops up in other areas too. Tell me more.
Oh, absolutely. Think about it, even just in our daily lives. We take in tons of information and then simplify it to make sense of it all. It's like our own kind of observation, wouldn't you say?
Right, like our brains have this spam filter trying to keep things manageable.
Exactly. We group things, make mental shortcuts, just to navigate the day-to-day. Like, take learning a new language. It's not like we're walking around listing off grammar rules in our heads, right?
Thank goodness for that.
Right. We just start talking, making those connections without even thinking about it between what we want to say and the actual sounds, the structure of the language.
Our brains hardwired for efficiency, it's kind of impressive. But how does that connect back to, say, math? That seems like it should be pure logic.
Even in math, we're acting as observers, imposing our own need to simplify, to make it understandable. I mean, imagine math without those shortcuts. Trying to work with the absolute basics, the foundational stuff, for every single calculation, our brains would melt.
Like we'd be stuck counting on our fingers forever. No thanks.
Exactly. We take this huge sea of mathematical possibilities and we chunk it down into concepts, theorems, systems, things we can wrap our heads around.
It's like we're those explorers making the first maps of a new continent. We don't need every little rock and tree to get the lay of the land. We need those big landmarks, right? To build a picture that works.
Exactly. Our understanding of math, it's always an approximation, shaped by this need we have to categorize, to make sense of things. And this act of, like, zooming out, making those bigger equivalences, it pops up in some really wild ways when we start thinking about the universe as a whole, too.
Okay, now we're getting to the really big picture stuff. I think I see where you're going with this.
Think about black holes, right? Those cosmic heavyweights. Some physicists actually think they might be the universe's ultimate observers, shaping reality for everything else.
Hold on. How do we get from black holes swallowing light to them deciding what's real?
Well, remember how we were saying that observation might be what collapses those quantum possibilities, makes things definite? Some think black holes, with all that gravitational pull, are basically doing that on a cosmic scale. Always making measurements, forcing particles to pick a state.
So like a cosmic game of quantum roulette and black holes are in charge of the wheel? What happens if there aren't black holes around, though? Does everything just stay blurry?
That's where it gets even weirder. Some think, even without black holes, there's still an observer out there. The edge of the observable universe itself.
The edge? How does that even work?
Okay, so think of the observable universe like it's this bubble around us, right? All the light, the information that's had time to reach us since the Big Bang. Past that, who knows, more universe probably, but we can't see it. The light hasn't had time to get here yet.
So like a cosmic horizon we can look out to, but anything beyond is basically in the dark.
Right. And kind of like how nothing escapes a black hole's event horizon, information can't cross back over this cosmic boundary to reach us. It's a one-way trip.
Okay, so we have this edge, this cosmic point of no return. But how does that make the universe an observer exactly?
It's the one-way flow, that cosmological horizon, that some physicists think could be enough to make those wave functions collapse, to give us the definite reality we're used to.
So even without black holes, there's still some kind of observer out there making the big calls, even if we can't see it directly. That's trippy. But what about us in all of this? Are we just along for the ride?
Not quite. Remember, even with these bigger frameworks, our own observations, our choices, they still matter in shaping our experience. It's like we're little whirlpools in a big current, right? We're getting pulled along by the river, but we still have our own little bit of motion, our own effect on the water around us.
I like that. Kind of empowering in a way. Even if we're not steering the whole universe, our choices still count in our own little corner of it.
Absolutely. And that brings us back to that equivalencing idea. It's not just how we simplify the world. It might be built into how the universe itself works.
Okay, now you really have my attention. What do you know?
Some physicists think that at the most basic level, space and time, like the very fabric of it all, might not be this smooth, continuous thing we experience. More like they're made up of these tiny, discrete units, kind of like imagine pixels on a computer screen.
Wait, are you saying reality itself might be pixelated, and all this smooth space and time we see is just our limited senses tricking us?
Exactly. Like when you look at a digital image from far away, it looks smooth, right? Because our eyes can't pick out the individual pixels. Our brains might be doing that with space and time, smoothing over the graininess to give us a seamless experience.
That's wild. So our brains are basically creating a VR version of reality, and we just think it's the real deal.
That's a great way to put it. And this pixelated reality idea, where space and time aren't what they seem, it has some pretty big implications. For one, it could help us understand those black holes, those regions where gravity gets so intense that space-time itself starts to warp.
Okay, you've got me hooked. How does pixelated reality tie into black holes? Okay, you've got me hooked. How does pixelated reality tie into black holes?
All right, so imagine you're zooming in on a digital picture, right? At some point, you hit that pixel level, and it's all, well, blocky. No more smooth image. Some physicists think something similar might be happening with black holes. As gravity cranks up, we're basically trying to zoom in on space-time itself. Eventually, we hit those fundamental units, those pixels of reality, and the whole smooth picture just kind of breaks down.
So black holes are like glitches in the universe's code where the rules stop making sense?
It's a pretty compelling idea, and it actually connects to this whole other mind-blowing concept that our universe might be, get this, holographic.
Okay, now we're really going down the rabbit hole here. Holographic universe. You mean like our reality is just a projection, like a literal hologram?
That's the gist, yeah. Think about a normal hologram. It's a flat surface, but it creates this illusion of a 3D object. Some physicists believe the universe might be structured kind of like that. All the information about our 3D reality could actually be encoded on some distant 2D surface.
Whoa. So you're saying our reality might just be a cosmic movie projected from some super far away screen, but then who's running the projector? And what does that even mean for us, for our place in all of this?
The big questions, right? And it leads right back to that observer problem. Because even if it's a hologram, even if reality is at its core pixelated, it's still our observation, our interaction with that information. That seems to be creating the world as we experience it.
This observer thing, it's like an onion. Peel back one layer and there's another head scratcher underneath.
That's what makes it so fascinating, don't you think? It's a journey that never really ends. And as we learn more about the observer, we're not just figuring out the universe out there, we're figuring out ourselves, what it means to perceive, to be conscious, to even exist.
It's kind of humbling when you think about it like that something as simple as observation might hold the key to everything.
And wouldn't it be something if it turned out we weren't just observing the universe, but actually playing a part in creating it?
You mean like that participatory universe idea, where our choices, our observations could be influencing things on a quantum level?
Exactly. It's a tough one to wrap your head around, but it really makes you think about free will, destiny, even time itself. If we're not just passive bystanders, if we're actively shaping reality, even in some small way, well, that changes everything, doesn't it?
It's both mind-blowing and a little terrifying to think we might have more power than we realize.
It does make you wonder about the responsibility that comes with that, however small it might be. But no matter where this all leads, the observer problem reminds us the universe is a lot more connected, a lot stranger, and more wonderful than we often give it credit for.
Absolutely. And maybe sometimes asking the right questions is just as important as finding all the answers. It's about embracing the mystery, you know?
Couldn't agree more. We may not have all the answers, but the searching, the exploring these mind-bending ideas, that's how we push the boundaries of what we know.
And on that note, I think we've given our listeners plenty to ponder for today. Thanks for joining us for this incredible deep dive into the observer problem. It's certainly given us a lot to think about.
The pleasure was all mine. And hey, next time you're looking up at the stars, remember, you're not just seeing a bunch of distant suns. You're looking at a universe that might just be looking right back at you.
Until next time, keep exploring, keep asking those big questions, and keep diving deep.